Hello and welcome to another free code session. My name is Jason Bach. I'm going to continue working on this allow ref struct anti-constraint on type parameters, issue, enhancement, however you want to view it. First thing I want to do though is cover the thing I mentioned at the end of the last episode about projected types, and one thing I think I'm going to do there. So let me go to those issues. So this is an issue I brought up. This is an issue I found in the work that I've been doing for the 9 release of Rocks, which is there are some types like type reference, runtime argument handle, arg iterator, and pointers that you can't pass into generic to generic arguments or to generic parameters. We already have a way to handle pointers though, so that we can generate a type when we're doing all the mock generation for a pointer type. And given what I'm going to show in the next issue, I thought, well, I had some ideas here. But then I realized, I added this note here. Then I realized, well, wait a minute. What I would probably end up doing for these types is essentially the same thing I'm doing for pointers. So if I can slightly make the generation of all the pointer projection code generic, I don't mean generic as in generics, just generic, then I could use that for these 3. I've been thinking about this. It's a very, very, very small issue. But what this ends up doing is for types like field builder, which I don't know why you'd want to mock. But if you did, we've got to handle this in one way or another. And so I'm thinking if we have this notion of a projected type or however I ended up doing it, I could do it for any type that I run into in the future and then just generate the necessary projected code infrastructure and use it from that point on. So I think I'm going to do that, especially when I look at potentially doing, I think it's this one. Yes, reuse projected code. So one of the things I've thought about is if I use something like an int pointer and it's on a given interface, for example, I generate all this code in this projections type and then I use it within these handlers. What I'm thinking of is, could I do something where I put these projections in a partial class, and I don't know if you can do that with a static. I'm not sure. That might blow up in my face. But put it in the same namespace as that type, and then put like the argument for int pointer there. And maybe put a callback there, or maybe do the evaluation delegate there. I'm not sure how much I can do with this, but the point is I could say when I'm looking at the model, have separate models made for projected types, like pointers, like the ones I've just mentioned before, and say these need to have projected types. And then we put them in one place rather than making them for each instance we run into. Again, this is not a big issue, but it's one of these little cleanup things that I think, if I can get this to work, would be really nice. It's just it lets me handle a couple of other types that I normally couldn't. It reuses an idea I already have, and it makes all the code reusable when I run into it, and that we only do it once rather than doing it for every single type I'm running into. I think that would be cleaner. So I will be doing this in future episodes. At least I'm going to try a proof of concept, see if this all works. But that's where I'm looking at with these 2 things. And then I think what I will do from that point on is, because we're doing these, essentially these, the biggest one left would be static abstract members and interfaces. And then the rest of them can technically fall off the cliff if they do. It's not a big deal for the rest ones to actually make it or not. So that's the plan. Let's get back into this issue and see how I can handle it. So I think what I want to do is jump into this one first, type reference model. And what I want to do here is add the allows, like if I say this dot allows ref struct, is I say type as I type parameter symbol question mark dot allows ref like type false. And so I'll say the same property name here. I'm a little leery about this because all this will work and it will be safe, but I'm making a type reference model start to go beyond what it should be doing, arguably, which is, but I do that down here. Like I'm looking at if it's a pointer type or a function type. I could say if type dot, what is the thing down here? Symbol type kind. So if I say type kind is parameter, I bet, equals symbol kind type parameter, then I would do this, you know, but this is kind of the same thing here, which is I try to cast it. If it works, I get the value. Otherwise, I'll just return false. And I don't have an allows ref type. Let's just stick that down here. We'll say internal bool allows ref. Well, wait a minute. What did I just call it? I not renamed it, but took the name of this. And let's just do that here. So we will say get. Perfect. So now we've captured that. And that was the first thing I wanted to do, but now we got to use it. So what we have to do now is find where I'm actually doing something like this in the current project. And there should be a handful of them. So in the extensions, we have a context that's just creating the code. Property expectations, I'm betting, yeah, this is in the setter. So what we want to say here is either it's a ref-like type or property parameter type allows ref-like type. And so I bet I'm going to be doing this in a lot of places. You could say, why don't I put these two together? I want to keep them distinct because to me they feel like they're distinct things. A bool or like data, if I said it's a ref struct data, is it a ref-like type? Yes. Does it allow ref-like type? It doesn't make sense. Whereas if I'm using a type parameter, then saying allows ref-like type, that I think makes more sense. You could also argue and say, well, wait a minute. Property parameter type, we're saying property submethod parameters. It should be on the parameter model, but it's the type of the parameter. So I'm going to go with that and just kind of run with that idea. So here we say the same thing. We're going to say parameter type. And we just are going to keep going with this. So I'm going to add this in. Thank you. I like that you're picking up on my jam here right now, and that I'm appreciating. I like that. Good. Yes. We take those. And then there's only going to be these left on indexers. You picking up on what I'm saying here? No, fine. Type. Wait. We got to do a dot there. There we go. And then this one, yep. Come on. And then this one. Okay, so now what I'm going to do is we're going to say save all these changes. What I'm going to do now is just shut down, start up again, and rerun all the unit and integration tests. Because this should not have broken anything. If anything, what it would have done in my tests, if I come back here and I go to the constraint tests, it might actually fix this. I'm not sure. It might break because, and why do I want tabs everywhere, tabs. I put spaces there and I put the code in an issue in GitHub because it does read a little bit nicer when you do it that way, but I just like tabs. Tabs are the way to go. You can't convince me otherwise. Don't even try. So some of this should all change. The other thing though is if we return one, I have not addressed that. So this is a parameter, but now we need to do something where we're looking at let's say, I think it's global system.func. That's what we want to look for. And there should be a handful of these as well. So we want to do the same thing. Property type allows ref-like because that's the return type. Yep. You gonna feel me? No. Or method return type allows ref-like type. Blasting these out as quickly as I can without doing stupid. This is interesting. So delegate builder. This is just a delegate builder if you need to do a regular old delegate. And since we aren't checking it here, I'm not going to do it here. Could come back to bite me, but so let's save those changes. I'll shut down, start up again, and I'll see what the results are like. Okay, we've got good success. The integration test passed. There's the one test with the constraints I just added that doesn't pass. I think I have to just do some changes there with the expected code, and I think I made a interface method that doesn't have an implementation or something. I don't know. I got to go look at that real quick. The code generation tests, they fail, but it's the failure that we know about with typed reference. So we're good for now. So let's do commit and say 331 added code to handle allows ref struct. Still needs some cleanup. Good. Okay, so let's go to the test that's failing. And first of all, let's comment all that out. Now, the interesting thing that this failed on is saying the method operation is not implemented. Generate with anti-constraint. Oh, yeah, that would make sense because I did have some code here that was running before this, and and it threw not implemented. There you go. Okay, so let's run this, and it fails. So let me just do some copy pasta. I'll be right back. Okay, we're close. I think we're close. We do see ref struct argument here. Say t allows ref struct. So that's good. We look at data and we do handle the callback. The return value, I think, is a little broken because we do not realize that it should be a return value as a func and not that. And so we're getting an error with that. But if we keep looking, we should see, yep, there's a ref struct argument here. And I think if I look at down here, the adornments, that should be a func of t. Yeah, it does realize it's a func of t. This one should be a handler of that. Okay, I think it's all good except this one case. We missed that. And so I want to be a little bit more cautious about not the copy replace that I just did, but the fact that it didn't find it is a little... Well, let's look at when we build a void doesn't matter. It's the value. So here we should be saying somewhere, and I don't remember where, but it's somewhere in here. Yes. Or method return type is allows ref like type. Now we should be doing that. Okay. Now I think this is called within the indexer, the mock method value builder. God, that is loud. This is create. This is create, which we only care about with that case, no parameters. And then this is the indexer builder. And we do that. Why is it not on the parameter builder? Parameter builder. Or property. I'm sorry, property builder. Yes, we missed it here. Property type. There. Okay, so now what we should see is when we call this one, it should be that. Still fails. And it's because we're off. So I didn't quite do what I thought was supposed to do with the code change. So we come down here. Oh, it's the exclamation, the emphasis on the wrong syllable. I got to flip the exclamation point I just put in the wrong spot. Okay. So we don't put it here. We have to put it there, which makes sense. Now it passes. Yay. Yay. Okay, so we did all that, which is good. And now what I want to do is, now Control M doesn't work. I don't know what I did to break that. And how do you do that with a keystroke? Is there let's see, run tests, breakpoint, run the cursor, outlining, collapse, toggle outlining span. Oh, is it just, no. Is something funky with my keyboard now? I mean, it knows control. Yeah. So it's supposed to be control M, but it's not doing that. Even though if I show it outlining, control M, there's stop outlining, which is not what stop hiding current, toggle all outlining, toggle outlining expansion. That is literally control M. I don't know what I did to break this. It's annoying because when you get used to a keystroke that you've been using a lot to do something with, and then it doesn't work anymore, it's quite painful. Generate it in method. So now what we want to do is take this off here and put it on the actual methods. See, I was like, yeah, let's collapse all this. No, you can't. So we got to do it that way. God, that is just annoying. I don't know why it's broken that way. I know I've said that like 3 times already. So this one actually should not have this anymore, and then, wait a minute. No. This is the right one. Let's hope I did not screw it up. It's this one. We take that off, and then we have to have use data T here, and then return data T here. And that takes this and this. Okay, let me get the code and then I will see what happens. Okay, that works too. So it now puts them on the method where it needs to. So that's good. God, my computer, I was thinking about maybe taking some time today and driving to the place that I got the computer at and asking them to take a look at it, but I'm just not going to have time, and I'm going to regret it because, like I said in the previous episode, it's like when your car makes a noise and you just turn up the radio and hopefully you don't hear it. I was thinking I could just put it under my table, which it really should, because it's got that the fans, it got that rotating LED glowing color thing, and it changes it randomly. It's like, oh yeah, that's nice and cute, but I also don't want that extra light on me when I'm recording. And then it would also, there's a light over there that I use, nice soft lighting, that would actually, because this computer won't be there anymore, and then when I get back from my trip, I might just take the case off, try to blow all the dust out of it and see if I can figure out where the noise is coming from myself. I don't think anything's broken on it, but obviously it's a noise that sounds weird. It sounds like the noise you remember when we used to have hard drives, not solid state drives. And if it would start, grinding and running, it just sounds like that, which I don't have that drive. It's an SSD, just like everything is these days. But that's the sound it kind of sounds like, which is probably not a good sound. Anyway, I'm babbling. So I'm actually pretty good with this. I think we've solved the problem. If I look at all my things here, I do want to update. I really want to update documentation on something that's kind of trivial. I will regret it though if I don't. So we do that, we do that, we do that, we do that. Good. And we should update the changelog though. Always do that. Generic type parameters constrained with ref struct with allows ref struct are now supported. And that issue would be with the one we're working on right now. And that is 331. Yay, this is done. So I'm going to do the commit and the merge and everything else. But I think this is now complete. And this is the final thing I'm going to work on before I leave on my trip. I am not doing anything else because I do not want to go down another rabbit hole if at all possible. But we're making decent progress on 9. I'm feeling okay with the way things are going. The static abstract members thing, I really want to try to get something in, but I also don't want to rush it. And if I can't make it work, that's okay. But I think we're getting farther along with the 9.0 release, and that is a good thing. So I'm done until I get back from vacation. Thank you all for watching. Leave comments and questions below. See you in the next episode.